State and prove the Gauss's theorem. Statement: for each positive integer n is greater than or equal to 1, n is equal to sigma d divides n phi d, the sum being extended over all the positive divisors of n. Proof by induction on the number of distinct prime factors of n. Suppose first that n is equal to pk. A divisor d of n of the form of pr 0 is less than r is less than equal to k, which implies 1 p square so on p raised to power k all are or all the divisors of n. Thus sigma d divides n phi d is equal to phi 1 plus phi 2 plus so on phi pk is equal to 1 plus p minus 1 plus p square minus 1 plus so on pk minus pk p raised to power k minus 1 is equal to pk. Thus the result is true for all the integers and that contains only one factor. Now let us suppose that result is true for all the integers m is greater than 1 that contains r minus 1 distinct prime factors, that is m is equal to, that is if m is equal to q1 raised to power k1 into q2 raised to power k2 so on qr minus 1 raised to power kr minus 1 for all values of I. 1 is less than equal to I is less than equal to r minus 1 qi, the primes and integers ki greater than equal to 1, then sigma d divides n phi d is equal to m. Let n is equal to p1 raised to power k1 into p2 raised to power k2 so on pr raised to power kr for all values of I is less than equal to I. 1 is less than equal to I is less than equal to r. Now pi are the prime and the integers ki is greater than equal to 1. Let n dash is equal to p1 raised to power k1 into p2 raised to power k2 so on pr minus 1 raised to power kr minus 1, then n is equal to n dash into p r raised to power kr, greatest common divisor of n dash and p r raised to power kr is equal to 1. Any divisor of d of n is of the form d dash pr raised to power t, where d dash is a divisors of n dash and 1 is less than t is less than kr. Therefore if d1 d2 so on ds are all the divisors of n dash, then d1 d2 and so on ds pr d1 pr d2 pr ds so on pr raised to power k r into ds are all the divisors of n. So sigma d divides n phi d is equal to sigma I varying from 1 to s phi di plus sigma I varying from 1 to s phi pr di plus so on plus sigma I varying from 1 to s phi pr raised to power kr di is equal to sigma I varying from 1 to r phi di plus phi pr di plus so on phi PR KR DI is equals to I varying from 1 to R phi di plus phi PR into phi di plus so on plus phi PR raised to power KR into phi di equals to sigma I varying from 1 to R phi di bracket starts 1 plus phi PR plus so on plus phi PR raised to power KR bracket close square bracket close is equal to I varying from 1 to R I varying from 1 to R phi di into PRKR where n dash is equal n dash into PRKR since by induction hypothesis which implies n dash is equal to sigma I varying from 1 to R phi di is equal to n.